MySQL Security Basics Part 1 of 3. In this nugget, we undertake a 3-part mini-series on MySQL security. In this first part, we're going to look at, in particular, the operating system on which MySQL sits. Before we do that, however, we're going to look from a Ferris wheel perspective at an overview of MySQL security issues in general. Let's get to work. Overview of MySQL security issues. Let's take a look at some general principles of MySQL security that any DBA should be aware of. First of all, we have the host operating system. MySQL is not a server appliance as such. MySQL, as you know, is a relational database management system that needs a host operating system for its existence and functioning. MySQL is a cross-platform, open-source relational database management system, which means that it functions on a variety of host OSs, including Microsoft Windows, Nix being a generic descriptor that refers to Unix, Linux, and so on, a variety of different Nix platforms. If you'd like to get a list of all the specific Nix distributions that are supported by MySQL, see the mysql.com website. And also we have support for Mac OS X, a strong contender that some of you may be familiar with that runs on Nix actually, uses the FreeBSD kernel. Now then, we have some complexity here, don't we? Because each of these operating system platforms has its own security issues. An operating system resides on what's called a file system. And a file system is a structure that, in particular, organizes files and provides security for those files. MySQL in particular, we're concerned with the following file system structures. Of course, we're concerned with the database. MySQL, the database, isn't a data file as such. For those of you who are familiar with, say, Microsoft SQL Server, you might remember the so-called MDF data file, and then optionally creating NDF files. Well, in MySQL land, the database is really nothing more than a directory or a folder in your data dir or data directory on the file system of the host operating system. Really, the file system objects kick in at the table level, don't they, in MySQL? So our table objects are our file system objects. Further on, we have configuration files, in particular the my.ini in Windows, my.cnf in Nix. This is going to be our option file, as it's often called in the MySQL literature, also called a configuration file. And this gives us our startup variables, our startup options that the MySQL daemon or MySQL D uses at system startup. This can also pass client-level options that can ease the environment for MySQL administrators or MySQL users. Especially on a production server, we want to protect the option file against accidental or intentional hijacking or deletion. Log files. Remember when the previous nugget, when I talked about access control, we looked at the AAA model just a little bit, with the first A denoting authentication or credential validation, the second A referring to authorization or resource limits, and the third A referring to accounting or audit trails. Well, our log files, or MySQL's ability to generate an audit trail, obviously presents security issues for a MySQL administrator. If a bad guy is going to breach security on your MySQL server, one of the first things that he or she is going to want to do is cover their tracks, aren't they? They're going to want to make sure that you coming in afterwards, the next workday, or perhaps immediately after the event, are not going to be able to follow up and track after the activities that the bad guy did in hosing your system or in whatever activities that bad guy did on your system. Of course, all three of these MySQL file system objects store sensitive data. Your database table files, your MySQL config file, and obviously your log files. Your log files can contain query statements, can contain table and object definitions and declarations, and so on. We want to make sure at the file system level we're setting access control limits such that only authorized users can see those files. So we're dealing really with all three A's on this access control model. Now, I've want to make this clear to you, friends. This AAA access control model is not part of the MySQL exam objectives. This is just an extra piece that I'm bringing in from my own expertise. You can read more about it on the web. You're not going to be tested on AAA. You are certainly going to be tested on all of the black stuff. Basically, all of the stuff you're seeing on these whiteboards is fodder for your DBA2 exam. And anything I add in blue to highlight is simply to add on and expand upon the exam objectives. Just want to be clear about that, friends. All right, so we have the operating system being a point of security, and this is what we're covering in this nugget. The file system is another critical point of security that we'll cover in part 2 of this mini-series. And then in part 3 of this mini-series of 3 nuggets on MySQL security, we'll look at the network access portion. It makes sense because MySQL is a client-server RDBMS, supports remote connections. Whenever we have remote connections to a client-server system, we have the ability for all sorts of attacks. We have DOS attacks, denial of service, where somebody just wants to flood your server with bogus data with the aim of knocking your server offline and denying service to legitimate users. We have, obviously, remote administration attempts. You name it. Whenever you've got network, you have a possible vector of attack, period. OS security best practices. Let's start to drill in this nugget and focus specifically at the operating system level. As you and I both know, an operating system is software running on your server. Whether that server is a physical hardware box or a virtual machine, it doesn't matter a bit. And this software interacts with the hardware. And again, now in 2009, that hardware can be virtual hardware or legitimate physical hardware. It doesn't matter. And makes it go, doesn't it? Therefore, the operating system presents a baseline vector of attack for bad guys and presents a baseline security area for us as systems administrators to protect. Now, depending upon your shop, this may or may not be your purview or your responsibility for protecting. Now, our goal from an OS security point of view, and really our goal as DBAs or any information technology professional, is to minimize the attack surface presented by our host operating system. Now, what the heck is an attack surface? From an operating system point of view, an attack surface represents the area or the exposed surface. I know you're not supposed to use the same term in the definition as you have in the term, but the exposed area where a bad guy can breach the security on your system. Now look at it this way. The wider the attack surface, the more angles of attack that a bad guy can leverage to breach the security of your system. Now what do I mean by that? Well, look at attack surface as subsystems of your operating system. Your attack surface might be defined thus. Maybe we have firewall. Maybe we have user account security. Maybe we have patching and update status. You see what I'm saying? Depending upon how you have these various subsystems defined on your system, this is going to either expand or shrink the attack surface of your system. Therefore, if, for instance, your patching status is unpatched, at least in my mind, this would significantly expand the attack surface of your system. If your firewall is either non-existent or set to allow way too many ports, then this would, again, extend the attack surface of your system. And the wider you make the attack surface, you're like increasing the radius of the target that you're drawing on your server. And you're making your server really more attractive a target for a bad guy to attack, all right? So again, our goal is to shrink the attack surface by taking these various subsystems on your host operating system and make them as tiny as possible. Ideally, you want your attack surface small enough such that your server either appears completely invisible to a bad guy, just doesn't show up on his or her radar, or appears too much trouble for him or her to want to bother with. There's a principle among many bad guys, and I'm using the term bad guy to refer to any malicious user who has some kind of bad motive for breaching the security of your MySQL server, and it's the principle of low-hanging fruit. Given two MySQL servers, unless that individual has a really big reason for wanting to breach the security of your server specifically, if there's your server and another server that's got a bigger attack surface, that person, dollars to donuts, is going to try to penetrate the other box because it's simply easier to do, all right? Now then, let's look at some ways to minimize the attack surface. One, and these are suggestions that come directly from the MySQL folks, consider running a dedicated instance, a dedicated server of MySQL. Now that can be done either in hardware, which is obviously more expensive, to dedicate a hardware server running essentially your operating system and MySQL and as few other services as humanly possible, or you can do it virtually, which is a far less expensive way to go nowadays, with virtualization solutions coming out of the woodwork from a variety of different vendors. Nowadays, it's not only VMware and Microsoft who are in the market in virtualization, but you can see immediately, I think, the advantage of a dedicated MySQL server. The more services you have running on a server, think of attack surface as a rubber band that's either contracting or stretching. The more services you have running on a server, the wider the attack surface is potentially. Simple as that. Now, depending upon your staffing situation at your shop, depending upon what you have going on business-wise at your shop, you just may not be able to run a dedicated MySQL server. However, I present this suggestion for you because I do, and it's part of the best practices. Even if you're not able to run a dedicated MySQL server, what you can definitely consider is the IT principle of least service. And what this deals with is minimizing the service load on your MySQL server machine. Now, a service is generically defined in Linux, Unix terms. The term is daemon, D-A-E-M-O-N. In Windows, the same synonym is referred to as a service. This can also be defined as a background process. This is generally speaking a server process, a server executable that's set to run at startup, that runs in the background. There's generally not a foreground component, and it runs under the security context of a particular account. That's a good working definition of a daemon or a service. And the more of these bad boys you have running, the wider your potential attack surface. Because the wider your attack surface, the more plates your server has spinning, so to speak, and the more complicated your work is as a server administrator, and the more you have to keep up with bugs. Each of these services is coded by somebody. As you're updating software, bugs happen, and unless you're constantly on top of these bugs, vulnerabilities surface, and some bad guy is going to definitely capitalize on a vulnerability, and the next thing you know, you have a security breach. So if you're minimizing service load on your MySQL server, you're shrinking your service area. Now, how can you keep track of service load? In Unix, Linux, there's a PS command line tool. In Windows, there's Task Manager. There's also a really nifty tool called Process Explorer that's kind of like Task Manager on steroids. Now, as you probably know, you Windows folks, Task Manager comes standard with Windows. Process Explorer is a free download from Microsoft. But either PS or Task Manager will give you a running hierarchical list where you can see exactly what's set to run and gather input and data about those services. Finally, on this whiteboard, we should minimize the operating system accounts on your MySQL server. This kind of touches and carries over a little bit with something we'll take up in the next nugget on the file system, and that is something called least privilege. So there's two least terms that deal with information security, least service and least priv. By minimizing the number of OS accounts that exist on the server, you know it, it's pure logic. You're minimizing the attack surface because you're reducing the number of valid credentials that can be cracked with, say, a password guessing or password cracking attack. Heaven forbid, something like a directory services password dump, a password hash dump attack, password file attack, something like that. Anything that attacks the password accounts directly, The fewer of these accounts you have on the server, the less likely of a breach you're going to have. Parenthetically, I want you to see here, I've already mentioned this, and at this point, by the time you get to the DBA2 objectives, you should already have this idea firmly embedded in your souls. But you should know that your OS accounts in Windows or Linux are not equal to your MySQL accounts. They're completely separate things. And that brings up an important point that we'll take up in the next whiteboard, actually. MySQL best practices. Here we assemble a laundry list of some additional security-related suggestions for MySQL, particularly related to the operating system function. First, we have the suggestion, don't run MySQL as root. Now, you Linux Unix people know and have known for a long time that you should never log on to a Linux Unix server as the root user. Instead, you should elevate your privileges on an as-needed basis using the sudo command. Windows users and the Windows operating system has been slower to come to the party with the secondary logon service and the run as command, and then more recently with Windows Vista, Windows 7, Windows Server 2008 with user account control. Mac OS X has the sudo command and a graphical analog to this. So similarly, when we install MySQL, we want to make sure that the MySQL daemon is not being overprivileged. Now, I mentioned a little bit earlier in this nugget the notion of least service, where we reduce our attack surface by making sure that we don't have unnecessary services running on the MySQL server. Here we call to mind the other least principle of least privilege. Not only do we not want to log on to the MySQL server as root or as too high a privilege a user, the reason for that being, if a bad guy or some malicious process were to hit your system, it would typically execute under the user account context of the currently logged on user. And if the currently logged on user is an administrative user, why, the hijacked process would then have that level of access to the local operating system and therefore MySQL. Not a good thing. Depending upon how you've installed MySQL on the system, particularly in a Nix environment, you should definitely, best practice, create a separate standard user account. Traditional best practice says create an account called MySQL. This is an OS account now. And you give ownership of your MySQL binaries and files to the MySQL user. And you use standard chown and ownership commands to give ownership of MySQL files to that user. And this, in a sense, kind of sandboxes MySQL and ensures that MySQL is owned by a non-privileged account. On the Windows side, you can do a similar thing by creating a non-administrative service account. Again, you can call it MySQL or you can call it some other name. Some administrators prefer creating service accounts that have some really nondescript name, like maybe John or maybe XYZ, something that would not give a malicious user any idea that that service account is attached to the particular service. After all, if I were a bad guy and I enumerated the user accounts on a target system, and I saw a user account named MySQL, well, that would tell me a couple things about the system, wouldn't it? It would tell me that dollars to donuts, MySQL is running on that system, and number two, that account is probably the owner of MySQL on that system. All right, so that's an important principle that you might want to look at in your production environment. Another thing, and this again comes from the MySQL folks themselves, is to consider physically separating your production and development boxes. You probably do this anyway, but just to reiterate the importance of your development and production environments being physically separated, not just on virtual servers on the same physical hardware, but physically separating them, not just even on separate physical servers, but maybe even in separate rooms. Microsoft has a really great white paper, actually an entire schema of security principles called Defense in Depth. You might want to look at it. It's got some really neat ideas where they look at security as kind of, have you ever seen those nutcrackers where one fits inside the other, inside the other, inside the other? It's a similar kind of idea where you look at security and information technology from the outside in or the inside out, where on the outermost layer you have physical security, the actual physical environment, the server room and the physical space where your servers are stored, the locked doors, the humidity, your fireproofing, and all of that kind of stuff. And then you work your way into the box to the operating system level and so on and so forth. Anyway, by physically separating your production and development boxes, you're adding layer upon layer of security in that defense in depth model. Yet another best practice for MySQL security at the OS level is to audit your servers. Now, if you have the moolah to be able to do a third-party audit, so much the better. There are plenty of contractors out in the world that are more than happy to take your money, and in return for this, the service that they'll provide is, well, they'll do a lot of things. They'll perform what are called penetration tests and test the security that you have currently in place on your MySQL servers, and heck, even your non-MySQL servers. They'll look at your entire server environment and give you suggestions on how you can harden your security situation. And they'll also look at your compliance if you're under, for instance, Sarbanes-Oxley or HIPAA or other governmental regulations. Auditors can come in and give you evaluations and suggestions to make sure that you're not going to be exposed legally in terms of shortfall with those. So that's something else to put in your theoretical pipe and smoke. Yet another suggestion is to consider operating system virtualization. On the Linux Unix side, there's an old school yet still possible technique known as the chroot jail, which is where you can install MySQL in its own virtual disk root. On the Windows side, you can consider running MySQL in a virtual server environment, as previously discussed. This completely sandboxes or isolates your MySQL installation from other services running on the same hardware. This final suggestion isn't tied to the operating system specifically, but it bears mentioning because any paper you read on improving MySQL security mentions it in point 1, and that is to remove your default database and any default MySQL accounts, besides the root account, of course. Now, depending upon which MySQL you install, that is to say whether you've installed the Windows or Nix version, you may find a database that you'll rarely, if ever, use, and that is an empty database called test. Some DBAs ignore this test database, others decide to drop it before doing anything else. I'm one of the latter category. I think if it's not serving any purpose, get rid of it, because any object that's sitting there without an explicit purpose represents, and we've discussed this before, part of that attack surface. Because anything or any object that's sitting either in the OS or in MySQL that's being untended represents a sheep that's wandering away potentially from the shepherd that can be capitalized upon by a malicious user. So I would recommend you drop that test database unless you have a good reason for using it. And if you are going to use it, make sure you secure it by applying appropriate privileges to it. Now, as far as your default accounts, again, depending upon which distribution and operating system platform you're using with MySQL, you may find an anonymous account or an empty blank username account in your MySQL.user table. Bad idea unless you absolutely need an anonymous user. Now, we talked a little bit about user security earlier in this course, and I gave you a couple good reasons when you might want to have an anonymous account. But frankly, in practice, anonymous accounts are rarely used, and your mileage may vary on that. But you can easily drop user using the drop user command, or you can run a delete statement against the MySQL.user table to clear out any anonymous accounts. Finally, you'll definitely want to change passwords and put strong passwords on your root account and any other privileged accounts in your MySQL.user table to make sure your password security is as strong as possible. But wait, there's more. The final piece here is what I call other aspects of operating system security. And this is general stuff that's not specific to MySQL, that's covered on your exam objectives, so you do have to know it. and really is a point of any operating system, Linux, Windows, whatever, and you can take this away with you for any information security or information technology scenario. First, the issue of software update or operating system update. Specifically, we have some technologies for Windows. We have what's called Windows Server Update Services or Windows Update. Now, on a one-to-one situation, on individual servers, you can always manually do an update. As you probably know, if you have any experience with Windows, you can just tap into the Microsoft Update website. In an enterprise environment, of course, you'll want to denote one or more target systems that go out to the Microsoft website, fetch the updates. This is going to be your WSUS server, and then your other servers in your enterprise and of course, your client machines are going to pull all those updates locally from your single point, your WSUS server. This, of course, gives you as an administrator full control over your updates. Updates sometimes break things as well as fix things. You may know that as well from bitter experience. So you have the control factor. And of course, you have control of bandwidth because instead of all of your servers individually polling Microsoft.com, and even more so, all of your users individually polling across the web, pulling those updates down, you're doing this at potentially 100 or 1,000 megabits per second, all on your local area network. It's a really good deal. What's more is that we have a similar kind of deal on the Linux side, the Red Hat network, and also in SUSE Linux, we have similar kind of centralized update technologies because more and more, as you probably know, we have Enterprise Linux, the two main ones being SUSE Linux and Red Hat Linux. So therefore, we need to have an enterprise solution for deploying updates. Again, this is really basic stuff. We're not needing to get into any details. After all, this is a MySQL exam. Take-home message here is, in reducing attack surface for our MySQL server, it's a great idea to keep software update on our MySQL server, and also, by extension, to keep our MySQL server software up to date to reduce our attack surface. Of course, firewall refers to hardware and or software that is going to monitor and control incoming and outbound traffic. We can set rules on protocols and ports and IP addresses. We have the question of software versus hardware firewalls. I'm sure you know this. Hardware firewall is going to give us much better performance than software. There's the counterbalance. Do you run both? Again, in an enterprise environment, probably not. But again, this is another aspect of operating system security that we need to be aware of. Antivirus, anti-malware. Again, we have the question of running the client locally on the server, and do we maintain updates centrally, similar to how we do in the first bullet point. Obviously, the point of antivirus or anti-malware is to keep our servers as free from junk as possible. As DBAs or as systems administrators, we're obviously not browsing the web from the server as we would from our desktop workstation, so this may not be as point-blank critical as an antivirus client is on a desktop machine, but it's certainly something to keep active and keep up to date with. What's news in October 2009, this is old news perhaps by the time you're watching this nugget, is T-Mobile critically lost a lot of data for its users of its Sidekick messaging telephone device because T-Mobile has not been backing up their data in its cloud service database. Really just a bonehead move in my opinion. Therefore, this is an absolutely crucial with all uppercase letters aspect of operating system security for MySQL, for our other mission critical applications, for our user data, and for the operating system, for everything, making sure we have a strong and solid backup strategy in place. And not only that, we want to make sure that we perform trial restores, because one of my favorite expressions is a good backup is only as good as its ability to be successfully restored. Finally, we have monitoring and auditing. Again, to call to mind the AAA, we have strong authentication in place to make sure that we're screening people on the front end legitimately and accurately. We have strong authorization to make sure that authenticated parties have least privilege in place for them. But we also need to keep monitoring and auditing without being overboard, because if we're overboard on our monitoring and auditing, we're going to adversely affect performance of our server. But if we do monitoring and auditing in a prudent way and in an intelligent way, we're going to boost the performance of our server, and we're also going to enhance the security and stability of our overall system. Frankly, and we're going to reduce the legal exposure of our IT department and our company as a whole. MySQL Security Basics Part 1 of 3 review. In this nugget, I gave you a high-level overview of those MySQL security issues globally that we're going to cover in this nugget, that we did cover, I should say, and that we're going to continue over the next 2 nuggets. In this nugget in particular, we focused on the host operating system, which in MySQL really turns into Windows, NIX, and Mac OS X, which really, as we know, is Unix Linux. Covered really a lot of ground. This was a pretty dense nugget. I hope you hung with me pretty well. We're certainly going to be building on our knowledge as we go through the next couple of nuggets, and really we'll be revisiting several of these topics throughout the rest of the course, so don't feel too overwhelmed. I hope that this has been informative for you, and I'd like to thank you for viewing.